Yes, good evening, guys, to all of you. How are you all? कैसे हैं आप सभी लोग? So, guys, this is the third practice session for you guys for ISRO 2025 exam. As you know, ISRO have given a number of vacancies for that. We are going through this practice session series. So, are you ready? Shall we start the session, guys? Today's subject we are going to take is the strength of materials. As you know, one of the highest weightage subject for ISRO, if you see the previous year's weightages, the highest weightage was there for material science. After material science, it is strength of material. Please tell me, am I properly audible and visible to all of you? Yes, I am fine. Arun, कैसे हैं आप? Yes, very good guys. Okay, तो मैं आपके कमेंट देख पाऊँ. यस, चेस चिप्स. तो सॉरी, आज क्लास हम ऐसे ही ले रहे हैं, मतलब बैठ करके. नेक्स्ट टाइम फ्रॉम द नेक्स्ट क्लास onward you will see the classes on the smart board. So today it was not feasible for me actually, because smart board class was having some electricity issues, that's why. So shall we start, guys? Please let me know, am I properly audible, visible to all of you? Yes, fine. Very good, guys. So let's start, guys. So, dear, I would also like to tell you कि by tomorrow and day after tomorrow, in upcoming 2 days, you will see some very important videos I will be taking for ISRO. Like one video I am going to take related to the most important topics as many student requested. Because last year also I have made that video and many questions were as it is from those topics. So most important topics video will be coming tomorrow, where I will be discussing approximately 25 topics from which questions are coming every year in ISRO. Second thing, guys, what I am going to do is weightage analysis, like from which subject, what kind of weightage you can expect. Okay, great, Arun. Congratulations to you. Really very happy to know that. So guys, this is some detail about me. My name is Dheeraj Sardana. I'm having around 13 plus years of experience. These are my areas of expertise for GATE and guys, and for other exams as well. And guys, when we are talking about ISRO, as many student requested, so Resultant have given two courses for ISRO. One is Udaan, where we are going for 150 plus hours of practice. And also we are going to provide the test series in this, where more than 50 tests will be available. And also we will be providing the PYQs, previous year paper of ISRO, and also a 500 question PDF, which will help you for more and more practice. So these all are the things you will be getting in the Udaan batch. Batch is available in Resultant Mechanical Lab. Udaan Pro is upgraded version of Udaan, where we will also be having 100 hours of revision, where we will be covering 100 hours for the revision of the subjects. Okay, so now without wasting the time, let's start. If you're interested for gate preparation, vision and target batches are also available. Okay, so now we are starting with the questions. This is the very first question for you guys. And whatever the type of questions I will be taking, it will be as it is as what ISRO is asking. Okay. No, dear, there is no issue. Only three classes have happened in the Udaan Pro till date. Till date, there is no delay happened. And even though if you will join from here, whatever three classes completed, you will be able to watch the recordings of those three classes as well. Okay, so you can definitely take that. So first question we are going to have is Young's modulus, and don't feel that this is an easy question. Yes, it is easy, but paper is always a mix up of some easy and some difficult questions, some lengthy and some short questions. So likewise, I have kept the session as well. Today we will be having 25 questions from strength of material. Okay, so for the very first question, Young's modulus they are asking. You know, Young's modulus is definitely defined as the ratio of stress versus strain, and this is basically longitudinal stress versus longitudinal strain. So you know this is the Young's modulus, so answer will be D for this. Okay, answer will be D for this. D is the correct answer. When we are talking about this volumetric strain and volumetric strain, when we are talking about this longitudinal stress, lateral strain, such ratio is not explained actually. So when we are talking about lateral stress versus lateral strain, so actually you must be aware of ki when we are going to have this, if a load is applied to this, you know, P is the load, A is the area. Okay. Generally, when we are going to have three modulus, actually E is defined as sigma by epsilon. G is defined as tau by gamma, and bulk modulus is defined as the sigma by volumetric strain, and the last one, Poisson ratio, is defined as the lateral strain by longitudinal strain. Okay. So actually this question is not very well framed, the options they have given. But next question is very, very well framed for ISRO point of view. Try to solve this question. The ratio of reaction Ra and Rb of the simply supported beam in the given figure is. Here you need to tell about the ratio of Ra and Rb. They have given the loads of 5T, 3T and 2T per meter for 2 meter. So you need to tell what would be the ratio. Let us see how many of you will be able to make the correct answer for this question. So dear, you need to find out the ratio of Ra and Rb. You can take the summation moment about A to B 0 first, and then you can take summation moment about B to B 0. When you will be taking this, you would be getting the things to be done. Try to solve that. You can find out Ra, Rb, and by that you can get the ratio. So you can take first of all summation moment at A to be 0. When you will be taking moment about A to be 0. So obviously, let us say this is Ra, this is Rb. Okay. So Ra is passing from a no moment because of this. This 5T is 2 meters away from this. This will be giving you the clockwise moment. So you can write plus 5T into. Then you can see this 3T will also create clockwise. So plus 3T, plus 3T, plus 3T into 6. Then RB will be creating anti-clockwise. So minus RB into 8. This 2T, you can assume 2T into 2, 4T at the center. So 40 into 5. This will be plus 40 into 5. Equating into 0 will be giving you RB. So you will be getting RB. This is 5 into 2, 10T, 3 into 6, 18, and then 28T, 28, 40, 80. 48T divided by 8. It will be 60. Now you can see the total load should be Ra plus Rb. What is total load? 5T here, 3T here, 15 and 4T here. So 15 and you can see 5 and 3, 8, 8 and 4, 12T. So you will be getting from here Ra will be 60. So you can see both are coming equal. So as both are coming 60 and 60, the ratio is going to be 1. So D is going to be the right answer for this. Please tell me, am I properly audible and visible to everyone? Everybody have done this? Please tell me. Is it clear for everybody? Do like and share the session, guys. We are coming up with new things every day. And as I already promised you, now you will see the resultant team more active for you guys for ISRO examination as well as for HPCL. Within 1 to 2 days, you will be getting HPCL test series available at resultant platform, which will definitely help you. Like last year also, many of our students who have purchased our test series got selected because test series was having the similar question as that of the real HPCL exam. Moving to question number 3, guys. So in ISRO exam last year also some lengthy question came. That's why I also kept some lengthy question. Next question is, in the statement, the buckling load for a cylinder column rigidly fixed at both the ends. Okay, so rigidly fixed at both the ends. So there is a column which is rigidly fixed at both the ends. Okay, rigidly fixed at both the ends. And they are saying the buckling load for a slender column rigidly fixed at both ends is about x times that of geometrical identical column, but both had hinge. There is another column for which we have both had hinge. Okay. Yes. Let us see how many of you will give the right answer. For this buckling load is pi square E I upon L is square. L is L here, you know? So you know that L is L here, L is L by 2 here. So obviously when you will be putting the value in this, answer will be coming out to be P fix is going to be 4 times P buck. P, this is the case of both had hinge. So P hinge. So obviously you guys have given the right answer. So don't worry guys, from next session onward, we will be on the smart mode. 4 is the right answer. No, dear, this is actually this question have also been asked in Civil services examination of mechanical engineering. This is also asked in ESC. This is also asked in GATE. Even this is also asked in DRDO. So this is a question which is asked in all these examinations in different ways. Also in ISRO, you will find similar question. Okay, so there are some questions which you find everywhere. So moving to the next question, guys. The ratio of Young's modulus to modulus of rigidity for a material having Poisson ratio of 0.2. So the ratio of E by G is given as 0.2. You know that E is equals to 2G into 1 plus mu. So let us see how many of you will be able to give the right answer for this. Try to solve it, guys. Try to solve it. So you know the ratio is going to be E by G. It equals to 2 into 1 plus mu. So they have given, okay, you need to find out the ratio of Young's modulus to modulus ratio of a material having, okay, 0.2 is Poisson ratio. Ratio you need to find out. Poisson ratio is given as 0.2. That you have to find out. Poisson ratio is 0.2. So I feel you will be getting the answer to be 12 by 5. A is the correct answer. Very good, guys. So this type of question is coming generally in ISRO exam. And also, if you find such questions are also available in ESC and civil services examination. So such type of questions are coming again. Moving to the next question, guys. A straight wire 15-meter long length is given. Is subjected to tensile stress of 2000 kgf per centimeter square. Whenever you see these types of unit, if everywhere you get the same kind of unit, no need to make the conversion. No need to go for SI units. Okay. You need to go for SI units if one side unit is kgf, they are asking in SI units. Here, everywhere they are giving in the same units. Okay. So no need to convert. So this is length given, sigma given, this is Young's modulus given, coefficient of thermal expansion alpha given, and they are saying a straight wire long subjected to tensile stress of this. Okay, coefficient of linear expansion. This is the temperature to produce the same elongation as due to this tensile stress in the material is. Yes, so they are asking you the delta T. So you can see the formula for sigma T basically is force by area. Okay, they're saying the temperature change to produce the same elongation. Okay, delta. Delta is PL upon AE. You can also write it as sigma L upon E. This is because of force and because of thermal expansion you have delta L is L alpha delta T. So you need to equate both. They are asking you what should be the change of temperature. Sigma L by E is equals to L alpha delta T. एक्चुअली गाइस वो ये पूछ रहे हैं कि डेल्टा टी की वैल्यू क्या हो कि थर्मल से भी उतना ही एक्सपेंशन आए जितना लोड के कारण आ रहा है मतलब जो आपने स्ट्रेस अप्लाई किया वट एवर स्ट्रेस यू हैव अप्लाइड 2000 kg per centimeter square so whatever because of this delta is coming the same is coming by delta t so you need to find out that value of delta t so for such question without calculator when you are solving you know L will be getting cancelled out by L sigma is given as 2000 okay divided by you know E is given as 1.5 into 10 की power 6 into alpha you have given it is 16.66 into 10 की power minus 6. So 10 की power 6, 10 की power minus 6 will get cancelled out. And you know delta T when you are finding out this is 2000. Okay, this is 1.5, this is 16.66. Okay, so you know zero point 0.5 of 16 is around 24. So this will be around 24 point something. Okay, this will be coming out to be 24 point something. So when you will be multiplying, dividing 2000 with 24 point something, so you will get exactly, sorry, approximately nearly 80 around answer. So 80 is going to be the correct answer. In ISRO also you have to do the calculations like this only because if calculator will not be allowed, you need to go like this. Is it clear? First of all, tell me. Because you know 25, 8 is 200. So from that logic, we have done like that. Clear everyone? Please let me know. Clear everyone? Please let me know. Yes, guys. This is a good question. Which one of the following favors brittle fracture in a ductile material? Elevated temperature, slow rate of straining, pressure of notch, presence of notch, or circular cross section. Yes, which one of the following favors brittle fracture? Mind the word in ductile material. Brittle fracture in ductile materials. I am fine, Syed and Sham Mohammed. I am fine. Dear, first of all, when we are talking about brittle fracture is happening without any warning. Without any warning. So that is why it is going to be like without any plastic deformation. Okay. So when we are talking about elevated temperature makes the material soft and ductile. So obviously A cannot be the answer because heating will make the material soft. So A cannot be the answer. Slow rate of straining cannot be the answer. Circular cross section cannot be the answer. Answer is presence of notch because I told you whenever a notch is present in the workpiece, notch reduces ductility. Whenever notch is present, notch reduces ductility. So always remember this thing that notch reduces ductility. So dear, notch if will be present, it will reduce the ductility of the material. So answer here will be C. So C is the most accurate answer for this condition. Moving to the next. A propeller shaft is subjected to maximum compressive direct stress of 20 Newton per mm square. We are having an element on which some compressive stresses are applied, that is 20 Newton per mm square. The maximum shear stress of 80 Newton per mm square, you know shear is shown like this. So we are having 80 shear. You need to find out the maximum tensile stress. So first of all, you know that the condition here is sigma xx is minus 20 Newton per mm square. Mechanical word, what you are saying is like whenever you are going to increase the temperature, then material is going to get softer. So in soft material, when you are talking about, we cannot say it is going to be a brittle fracture. Actually, when we are talking about the brittle fracture means like which happens instantly. Okay, in the soft material, you will not get the fracture instantly. Okay, means without deformation. Soft material will be easily deformable. So sigma xx is minus 20 here, sigma yy is 0 here, and tau xy they have given is 80 here. So they are asking you the maximum tensile stress. You know the formula sigma 1 comma 2 is sigma xx plus sigma yy by 2 plus minus square root of sigma xx minus sigma yy by 2 का square tau xy का square. So you need to find out sigma 1 comma 2. So sigma xx minus 20 plus 0 by 2 plus minus square root of, so minus 20 minus 0, it is going to be 10 ka square plus 80 ka square. So it is going to be minus 10 plus minus 100 plus this is going to be 6500. If you will see the 6500 ka square root, it will be coming somewhere 80.62. Okay, not even 81. So when you will see this, you can see minus 10 plus 80 you can take, minus 10 minus 80 you can take. One value will be 70, other will be minus 90. Magnitude wise, if you see minus 90 is bigger. If you see like plus minus you consider, then 70 is considered to be more than minus 90. In options, you have only one value. So 70 is going to be the right answer. Is it clear? But if option have 90, then 90 would be the answer. Because magnitude wise, 90 is the highest value. Is it clear? I hope you guys are getting it. Moving to the next question, guys. Next question is the plane of maximum shear stress has normal stress, that is. Maximum, minimum, zero, none of the above. The plane of maximum shear. So, my dear, the plane of maximum shear. If you remember, I told you in the principle on the principal plane, shear stress is zero. But on plane of maximum shear, normal stress can be anything. It can be anything. So there is no question of maximum, minimum, zero. It can be anything. So answer will be none of the above. Are you getting it? Everybody is clear for this question? Shall we move on, guys? Everybody is clear. Everybody is clear. Shall we move on? Yes, B is correct, guys. Okay, guys, we are moving to the next question. And as I already told you guys, tomorrow I will be coming up with a session of important topic for ISRO 2025. And the day after tomorrow, I will be coming up for the topic of weightage analysis. Like from which subject you can expect how many marks. So every alternate day you will have my sessions which will help you in preparation in an analysis of a closely coiled helical spring. So you are aware in the machine design and strength of material we have done this. If you will apply the compressive force on the helical spring, which of the following are negligible? Torsion, bending, axial force in the wire. Select the correct answer. So 1 alone, 2 and 3, 1 and 2, 1 and 3. Let us see how many of you will give the right answer. If you remember, dear, shear stress would be coming because of torsion, bending stress would be coming because of bending, axial stress would be coming because of this. If you remember, when we did the analysis of a spring, we assume the compressive force to be acting here. When you see the effect of this force at this cross section, we applied one force here, one force here. This and this made a couple. So you have seen the cross section of spring and you found one shear force and one twisting couple. Shear force was P, twisting couple was P into D by 2, if you remember. And because of this twisting couple, shear stress was quite high. Because of this direct shear, stress was very less. So dear, shear stresses were dominating. So normal stresses were negligible. They were negligible. That's why answer for this is 2 and 3 are negligible. B would be the right answer. Everybody got it? Please tell me. This is a beautiful question. This was a beautiful question. Yes, mechanical word, Arun, chest chips, Shreyas, got it or not? So answer will be B for this. Moving to the next question. Failure of a ductile material is best explained by. Ductile material का failure is best explained by principal stress criteria, principal strain criteria, distortion energy criteria or strain energy criteria. What should be the answer here, guys? Yes. So dear, if you remember, we have studied it in a nice way that when we are talking about the brittle material, the best theory was MPST. When we are talking about the ductile material, for safe design, MSST was good. But to define the failure, obviously MDET was better. So also you can see shear stress theory is not in the option. C is the right answer. Moving to the next question. Now this is a beautiful question because there are some cases where you need to remember the results. The strain energy stored in a simply supported beam of span L and flexural rigidity EI carries a central concentrated load. There is a simply supported beam. On this beam, we are having a load W. What would be the answer for this? You know strain energy. is half into, okay, let us use the Castigliano theorem. When you want to find out the strain energy, you know how to do this. This is AB, and you know this beam is going to deflect like this. You know, because of symmetry, here also support reaction will be W by 2, here also support reaction will be W by 2. So if you can say at C bending moment is, it will be W by 2 into L by 2. It is WL by 4. So if you want to find out strain energy, you can find out like this. Obviously, if you want to find out from A to C, it is going to be, if you take a section here, MXX, it is MXX square upon 2EI dx. This is the way to do, okay? And you can say because of symmetry, from here, if you take section X, then also the bending moment will be coming same. So you can also write the total strain energy. Here you need to otherwise integrate again B to C. And once again, mxx square dx upon 2EI. The best way is you can write 2 times 0 say L by 2. It is mxx square dx upon 2EI. And from that you can find out the answer will be coming out to be W square L square upon 96 CI. Okay, am I correct? Everyone, W square L cube 96 CI. So answer will be D for this. You can also do this like half into W into deflection. So half into W is the load. What is the deflection at this point when we find out? It is coming out to be W. It is W. You know na? What is this? L square by 48 EI. WL cube by 48 EI. So when you will be multiplying this will be coming out to be what? W square L cube by 96 EI. So by that way also you can easily find out. Answer will be coming out to be D for this. Very good, Aditya. Moving to the next question. Both the ways it is correct. Let us see the next question. This is a three-dimensional state of stress can be split into the two components. The hydrostatic state and deviatory component. The magnitude of the hydrostatic state pressure is given. Here, this is from the derivation of theory of failure. If you remember, I did MDET for you in theory of failure, and this question is from that derivation. Like if you are going to apply three stresses, let us say sigma 1, sigma 2, sigma 3. I told you this is the applied loading. Whatever loading you are going to apply on a element, that is going to do two things. One is it is changing the size of the body, other is changing the shape of the body. Size means changing the volume. The part which is changing the volume, we call it as volumetric. The part which is going to change the shape, we call it as distortion. Distortion or shear. So when you are going to say that we are going to have sigma 1, it is going to be divided in two components here. This is sigma 1 which will change the volume. It is which is change the shape, sigma 1d. Here it is going to be sigma 2v and here it is going to be sigma 2d. Here it is going to be sigma 3v, here it is going to be sigma 3d. In the paid courses of Vision and Target batch, I did the derivation of this. But in ISRO practice session, we will not go for derivation because here our target is not to go for research. Here our target is to qualify the exam. For that, I am directly writing. If you remember, we have applied two conditions in the derivation when I did. First condition was sigma 1v plus sigma 2v plus sigma 3v should be equals to sigma 1 plus sigma 2 plus sigma 3. And sigma 1v equals to sigma 2v equals to sigma 3v was equals to sigma v. From here you got sigma 1v is equals to sigma 2v is equals to sigma 3v was equals to sigma 1 plus sigma 2 plus sigma 3 by 3. So your answer is going to be A. So those who have studied, uh, so Suresh Suthar sir is there for motivating us. Thanks sir for coming, for joining the session. So guys, sigma 1v, sigma 2v and sigma 3v. It is going to be sigma 1 plus sigma 2 plus sigma 3 by 3. And this is how you can do this. This is said to be hydrostatic state of stress. And if you remember in the derivation, we also did sigma 1d plus sigma 2d plus sigma 3d 0. So here you need not to go for the derivation. You can directly remember this result. Okay, but those who studied for the gate would be aware that how we did this derivation. Yes, very good mechanical word. Chess chips, everybody. Wonderful, guys. Moving to the next question, guys. This is a beautiful question using the vectors. A circular surface area of 200 centimeters square is inclined to the x and y axis such that the unit vector normal to the surface is zero point 0.4 I cap plus 0.3 j cap. If a force of 200 kg acts on the x-axis, then the normal stress on the surface. So you are having a body like this. Okay. We have applied the force like this. But they are not interested for the stress on this area, but they are interested in finding out the stress on some other area like this, whose area vector is like this. So this is our force. This is our area vector. So when you want to write down the stress, you can write F dot A. Okay. So I feel everybody is aware of the dot product. So if you want to find out this, 2000 is the force. What is area? Area is given as 200 centimeters square. You know F dot A when you are doing. So force is given as 2000 kg. And this is in x direction. So you can write 2000 I cap. And what is area? Area is 0.4 I cap plus 0.3 j cap. So in the dot product, I will multiply with I, j will multiply with j. So answer is going to be yes. What would be the answer for this? Tell me, guys. Okay, this is the unit vector. So you need to multiply with 200 as well. Okay, yes. So 200, 2000 into 200 into zero point 0.4. I have done some mistake, I feel so. Yes. Have we done some mistake? Oh, sorry. Stress is force but area, na? So when we are talking about, we need to find out the stress. It is force by area. We did some mistake, I feel so. We are given the direction of area vector. You can write sigma dot A is equals to force. So from here, when you will be finding out the sigma, so I feel the answer should be coming out to be 4 kg per centimeter square. 4 kg per centimeter square. Okay. Okay. No issues. I feel some data issues are also there in this question. So leave this question. I will be rectifying this in the next class. Okay. Actually here, data is not given properly. Actually, there is some, you can say misprinting type of thing is there. Okay. Next question, guys. Next question. This is a very good question. In the given figure, the maximum bending moment at the fixed end of the cantilever caused by UDL is F. The bending moment at a section L by 5 from the end is. This question is a PYQ of civil services. This is the PYQ of civil services. Try to solve it, guys. Try to solve it. Sir, सिविल इंजीनियरिंग ईएससी 2025 में टेक्निकल में 228 मार्क्स एंड जीएस में 40 मार्क्स आ रहे हैं. सर प्री क्वालिफाई करने में कोई प्रॉब्लम तो नहीं होगी ना जीएस की वजह से. श्री राम मीणा, आई वुड लाइक टू टेल यू कि 20% marks are required. If 40 you are getting, there is no problem. You must be qualifying. I feel so. As per your category for sure. Okay, what would be the answer for this, guys? You are aware that when you are having a cantilever beam on which UDL is acting, if you are going to take at a section XX bending moment, bending moment at a section is written as minus W into X by 2. So it is bending moment at any section is minus WX square by 2. And if you are going to find out the bending moment at the fixed end, then bending moment at the fixed end is put x barabar L, it is minus WL square by 2. They are asking you what is the ratio of MXX by M fixed end. The ratio is minus WX square by 2 minus WL square by 2. 2 will get cancelled out, minus will get cancelled out, W will get cancelled out. But they have given x to be L by 5. So you just need to put the value L square by 25 divided by L square. Okay. So you would be getting 1 by 25. If you want answer in terms of percentage, you need to multiply with 100. You will be getting 4% as the answer. A is the correct answer. Please let me know, is it clear or not for everyone? Arun, chess chips, mechanical word. Please tell me, is it clear for everybody or not? Clear for everybody or not? Please let me know. Clear for everybody or not? Please let me know. Yes. Next question, guys. We have 5 more questions. This question is the ratio between the stress produced in a bar by sudden application of load, impact loading, as compared to stress produced by the gradual application of the load. So dear, they are asking you the ratio of impact stress by stress in gradually applied loading. If you remember, the impact value of stress is sigma static into impact factor. Impact factor is 1 plus square root of 1 plus 2h by delta static. And if we put h to be 0, you will get the minimum value of impact factor. That will be coming out to be 1 plus 1 is equals to 2. And when impact factor is minimum, that loading is said to be suddenly applied loading. As they have mentioned, application of load in sudden application. So it means you need to consider impact factor to be 2. So you will say impact stress is 2 times of static stress. So ratio of this is going to be 2. B is the correct answer. कोई बात नहीं श्रीराम मीना. GS is GS is difficult for everyone. It is not like you are the only person for that. Don't worry. You have good chance for that mains examination. So now concentrate there. The deflection of free end of a cantilever subjected to a couple M at its free end and having uniform flexural rigidity EI throughout its length is equals to. You can see we are having a cantilever beam which is subjected to bending moment M. I told you you need to remember 6 to 8 results. This is from that only. I feel everybody will be aware of that when we are going to talk about this, the beam is going to be deflected like this. This will be the deflection and this will be the slope. And if you remember, slope will be coming out to be at A point ml upon EI. Deflection will be ml square upon 2 EI. So ml square upon 2 EI is going to be the right answer as they have asked the deflection. A is correct. Very good, Shreyas. Moving to the next question. The next question is the structure shown in the figure is stable if. Actually, this question is a very important question for ISRO. They have taken X length here, Y length here. Here they applied a load of W on this side, and on that side they applied 2W. You know, it will be balanced if that moment is zero. You know, because of left hand side, the sum of complete UDL will be acting at x by 2 from the center. Similarly, here it will be acting at y by 2 from the center. This will be W into X. This will be 2W into Y. So you can write W into X by 2, 2W into Y by 2. You can find out here what is the relation between X and Y. W will get cancelled out. X square by 2 will be Y square. 2 will get cancelled out. X will be root 2Y. Everybody got it? The answer will be D for this. Clear, everyone? Yes. This is a beautiful question, guys. So, guys, tell me, do you want such free sessions on YouTube? We are coming with 3 sessions per week. Okay, 3 sessions per week we are coming. For good practice, you can join our Udaan batch where you are getting 100 to 150 hours of practice session plus 500 questions PDF plus test series of more than 50 questions, 50 papers plus PYQs. This is the offering in Udaan batch. If you want revision also, then you can go for Udaan Pro, where 100 hours of revision is also included. Okay. So if you want systematic preparation, you can go for batch. Otherwise, every week, 3 sessions will be coming on YouTube. A beam of square section of side A is placed in the following way. First, a beam is placed, sides are horizontal and vertical. If you remember, for this case, section modulus was AQ by 6. In another way, you can keep the diagonals to be horizontal and vertical, like this. For such case, if you remember, section modulus was AQ by 6 root 2. You need to find out ZA by ZB. So it is AQ by 6, AQ by 6 root 2. बिल्कुल सारे सब्जेक्ट का सेशन होगा मैकेनिकल वर्ड. Arun, for civil till now there is no vacancy came. When vacancy will come, then civil sessions will also be there. Answer will be route 2 here, I feel so. Okay. Like today we are having SOM session. On Saturday, Sunday, I will be taking like the session of production. So we are having alternate day session. Like today I am taking, day after tomorrow Suraj sir will take. Then Vikas sir will take. Then I will be coming. B is the right answer for this. Moving to the next question, guys. Two springs of stiffness K and KB are placed one inside the other so as to compress by the same amount under the applied axial load. The combined stiffness of the total spring will be. Yes, guys. Two springs of stiffness KA and KB are placed one inside the other. Okay, KA and KB one inside the other. Compressed by the same amount under an applied axial load. The combined stiffness. You can see one spring. Second spring is inside this. They are behaving like parallel connection. Sir, in Udaan batch, how many subjects are ongoing now? Chess sips right now. We are going with thermo, and tomorrow we are also starting so. Right now, these two subjects are going on. Okay, so will be starting from tomorrow. So will be starting from tomorrow. अभी नहीं आई श्री राम मीणा, जल्दी ही आएगी. आंसर विल बी डी फॉर दिस. पैरेलल में आपको पता है स्टिफनेस कैसे निकालते हैं. ठीक है. ओके. Which one of the following Mohr circle of stress represent the pure shear case? Which one will give you pure shear? Dear, if you remember, this is the case of axial loading tensile. This is the case of axial loading compressive. This is the case of biaxial loading. This is the case of pure shear. For pure shear, origin and center should coincide. C is the answer. Very good, everyone. Okay, next question doing, I am giving you this one. The phenomena of decreased resistance of material due to reversal of stress is known as. Let us see how many of you give the right answer for this. This is the last question for today. We will be coming up next session for production on weekend. Every week you will have one session of mind technical, one session of Suraj sir, one session of Vikas sir. 3 sessions every week. So you know the phenomena of decreased resistance of material due to reversal of stress is fatigue. That phenomena is known as fatigue. Conversion of elastic into plastic is known as creep. Okay. Removal of load, material regain its shape and size is elasticity. Resilience is energy stored till elastic limit. So answer is fatigue here. So guys, today I will be saying you goodbye for this session. But yes, for those students who joined late, I would like to tell you a very important point. That is, we will be having, if you have not subscribed the channel, please subscribe it, because for ISRO, we will be coming with a number of sessions, not only the practice session, but some other sessions which you are looking for. Most important topics, 25 topics, and weightage analysis for ISRO paper, like from which subject more weightage is covered. Okay, all these things we will be coming up. So just stay tuned with us, and these video will help you in your preparation journey. If you find with my name every year, I am helping the students with such videos, and you can see the comments on those videos. You will be really very happy to see that, because students found the same type of questions, whatever we tell in the important topics. And that's why for every exam, you can see the requests are available on my Telegram channel also. If you see, for PEL also many students requested, but at that time I was not available. Unfortunately, that's why I could not take that session. But now I am available. So I will be there with you for ISRO and for all other examinations, and will be helping like that. So goodbye guys for this particular session. Stay tuned with us, like, share and subscribe. Goodbye for this session. You can download Resultant Mechanical app to get more benefits. Okay, goodbye.